If you've ever watched the news during a hurricane or wintertime nor'easter, you've probably noticed that big storms spin over time as they travel. In the northern hemisphere, they spin counterclockwise. But if you were watching a storm in the southern hemisphere, you'd see it spinning clockwise. Why do storms spin in different directions depending on their location? And why do they spin in the first place? A storm's rotation is due to something called the Coriolis effect, which is a phenomenon that causes fluids like water and air to curve as they travel across or above Earth's surface. Here's the basic idea. Earth is constantly spinning around its axis from west to east. But because Earth is a sphere and wider in the middle, points on the equator are actually spinning faster around the axis than points near the poles. So imagine you were standing in Texas and had a magic paper airplane that could travel hundreds of miles. If you threw your airplane directly northward, you might think it would land straight north, maybe somewhere in Nebraska. But Texas is actually spinning around Earth's axis faster than Nebraska is, because it's closer to the equator. That means that the paper airplane is spinning faster as well, and when you throw it, that spinning momentum is conserved. So if you threw your paper airplane in a straight line toward the north, it would land somewhere to the right of Nebraska, maybe in Delaware. So from your point of view in Texas, the plane would have taken a curved path to the right. The opposite would happen in the southern hemisphere. An object traveling from the equator to the south would get deflected to the left. So what does this have to do with hurricane spinning? Well, at the center of every hurricane is an area of very low pressure. As a result, the high-pressure air surrounding the center, or eye, of a storm is constantly rushing toward the low-pressure void in the middle. But because of the Coriolis effect, the air rushing toward the center is deflected off course. In the northern hemisphere, the volumes of air on all sides of the eye keep getting tugged slightly to the right. The air keeps trying to make its way to the middle and keeps getting deflected, causing the entire system to spin in a counterclockwise direction. In the southern hemisphere, where the Coriolis effect pulls air to the left, the opposite happens. Storms spin around the eye in a clockwise manner.